Periodic table or periodic classification of elements. Classification in our daily life, with knowing or sometimes without knowing, we will classify the things to make our life easier. Suppose in our house, you have so many items. Basing on the utility of those items or the usage of those items, we will arrange them in a systematic manner. Some items we use for cooking our food. So we keep all these items which we use for cooking and kept in one room. Even our house was divided into different rooms. So the room which we use for cooking our food, we call it as a kitchen. And all those items which we used while cooking were kept in that room, and we call it as a kitchen. And one room was allotted for us to sleep. There we keep the things which are necessary while we are sleeping. That means cots, beds, bed sheets, pillows, everything. So that room we call it as a bedroom. Similarly, we room one of the room in our house for eating our food. In that room, we'll arrange the things which we use while dining our food. So we call it as a dining hall. And we kept one room for the guests. We call it as a drawing room. So without a specific scientific reasons, basing on the necessity of those items and the position of the rooms, we divide our house into different rooms and name those rooms, each room with a specific name, and we keep all those things in those rooms, specified rooms. That we call it as a classification. Suppose if you want to brush your teeth, you won't go to kitchen to search for the paste and toothbrush, or you won't go to your bedroom to search for it, or you won't search for it in the drawing room. You directly go to the bathroom where you have those items. Similarly, if you want to drink some water, directly you will go to the dining hall or in the kitchen where you kept it. Similarly, if you want to sleep, you directly go to your bedroom. There you have everything what is necessary for sleeping. Similarly, if any guest comes, he directly come to our bathroom. Is it? No, he won't come to our bathroom. Just we ask him to sit in the drawing room. So, basing on the purpose or the needs, we classified our house and arranged the things accordingly. Similarly, here in this universe, the matter is made up of so many elements, nearly so far 117 different types of atoms are identified. Each type is said to be an element. Out of those 117 elements, only 92 elements are naturally occurring elements. From ancient days, the elements are go on discovering. When the number of elements are increasing, to study each and every element separately, it's a laborious process. That's why scientists has a thought to keep a similar elements as one group. And as a group, if we study such elements, the properties of those elements and the differences in between them, it is very easy for us to find out the reasons for their specific properties. So they recognized the necessity of this classification. So the first attempt was made by a German scientist called De Bruyner. At that time, only 30 elements, nearly 30 elements were discovered. He first made an attempt to classify these elements. This we call it as De Bruyner's law of triads. De Bruyner's law of triads. So here in De Bruyner, what he has done, he take a group or cluster of elements with similar properties and he arranged them in a pattern of increasing of their atomic weights, so that he found in a triad, that means 3 elements with similar properties if he has taken, the middle element atomic weight is an arithmetic mean of first and third elements. Like that, he made so many triads like that, elements that obtained in those days, that is in 1829. In 1829, De Bruyner proposed this law of triads. According to him, for example, lithium, sodium and potassium. Lithium, sodium and potassium. The atomic weight of lithium is 7 and potassium is 39 and sodium is found to be 23. So when it make as a triad, the first element and third element is lithium and potassium. So the arithmetic mean of these two, that is 7 plus 39 by 2, the mean of those two atomic masses is found to be 46 by 2, that is 23. That 23 will be the atomic number of the middle element. This is one triad. Similarly, he make several triads like chlorine, bromine and iodine. In chlorine it is 35.5, this is nearly 80 and this is 127. So arithmetic mean 35.5 plus 127 by 2, it will be approximately equal to 81.25, which is nearer to the atomic mass of the middle element. Similarly, phosphorus, arsenic and stibnum. Phosphorus is 31, stibnum is 120 and arsenic is 75. So arithmetic mean is 31 plus 120 by 2, that is 151 by 2, that is equal 75.5. It is nearer to the atomic mass of a middle element. Similarly, calcium is 40, strontium is 88 and barium is 137, and arithmetic mean is 40 plus 137 by 2, it will be equal to 88.50. Such a way he arranged a group of three elements, a cluster of 3 elements kept in one place, so that they are similar in their properties. By that way he arranged nearly 30 elements in this pattern. But as new elements are discovering, this law was failed to explain the properties of all the triads. For example, if you take a group like fluorine, chlorine and bromine. Fluorine is 19, chlorine is 35.5 and bromine is 80. That means the arithmetic mean of fluorine and bromine is 80 plus 19 by 2, that is 99 by 2, that is 45, 99 means 49.5, 49.5. This 49.5 is very far away from the mass of chlorine. That means this law of triads is not applicable for these three elements which are similar in these properties. The same law was applicable for chlorine, bromine and iodine. But it was not applicable for fluorine, chlorine and bromine, which are also having similar in their properties. And if you take ferrous, cobalt and nickel, they are also very much similar in their properties. And we have osmium, iridium and platinum. They are also very much similar in their properties. Similarly, we have ruthenium, rhenium and palladium. They are also very much similar in their properties. But their atomic masses are very nearer. The arithmetic mean, that means the atomic weight of the middle element, is no way concerned with the arithmetic mean of first and the third elements. That's why this law was failed to explain or failed to fulfill the needs of classification which we require to study the properties of all elements. Then another attempt was made by Newland. That we called as a Newland's Law of Octaves. After the failure of Debonair's Law of Triads, Newland in 1863 made an attempt to classify the elements. It was known as Newland's Law of Octaves. We know that in musical notes, we have saptaswaras, sa, ri, ga, ma, pa, da, ni, sa. That means eighth node, eighth musical note is very much similar to first node. That means sa, ri, ga, ma, pa, da, ni. Eighth is again sa. That means 1, 2, 3, 4, 5, 6, 7 and eighth node is again sa. So that eighth one is resembled to first one. Similarly, when elements are arranged in increasing order of their atomic masses, every eighth element resembles in its properties with the first element. Taking this in a view, he arranged the elements in a systematic manner. At that time, nearly 60 elements were discovered. He tried to arrange the 60 elements in this pattern. In those days, these inert gases, that is helium, neon, argon, krypton, they were not discovered except those elements. The elements that so far discovered, he arranged them in this pattern, that is hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, then chlorine, potassium, then calcium, strontium, potassium, chromium, then titanium, manganese, ferrous, cobalt and nickel, copper, zinc, yttrium, indium, hafnium, cerium. Then bromine, rubidium, strontium, cerium and lanthanum, zirconium, dysprosium and molybdenum, rhenium and ruthenium. So he arranged nearly 60 elements like this. But this classification is suitable up to the elements, that is up to calcium. It has some meaning in the classification. In the rest of the elements, though they were present in the same group, the properties are not resembled. And the two elements were kept in same places. And some undiscovered elements are there. For example, inert gases, they were not discovered at that time. But here there is no place for those elements. Germanium, gallium, and so many elements are there which were not discovered at that time. So those elements have no place in this Newlands periodic table. Of course, it was applicable for those elements up to atomic weight 40, that is up to calcium. This classification is suitable and it will have certain meaning. But after calcium, for the rest of the elements, this law was not applicable, and let's make any advantage for the study of the properties of those elements. That's why this theory was also failed. But the arrangements of elements in horizontal rows and vertical columns is give a path for Mendeleev and other scientists to make a meaningful classification. This is regarding Newlands theory of octaves. Mendeleev's periodic table. As the classification made by Newland and Lothar Meyer was unable to reach the necessities or unable to explain the main purpose of classification of elements, Mendeleev made a successful attempt with a scientific approach for the classification of elements. For that, he proposed a law called as periodic law. Periodicity. The meaning for the term periodicity. Periodicity means appearance of one property, appearance of certain properties that appear in one element will reappear after a regular intervals in some other elements is said to be periodicity. What is meant by periodicity? Periodicity is a phenomena that reappearance of certain properties that we observed in one element after a regular interval in some other elements is said to be periodicity. The reappearance of properties of one element in some other element after regular interval is said to be periodicity. Now the question is, on what type of arrangement can we see this periodicity? So on what basis the elements are arranged in a series so that the properties that was exhibited by one element will appear after a regular intervals in some other element. For that, he has taken the atomic mass of an element as the main criteria, and he arranged the elements in increasing order of their atomic number, so that the properties that were observed in one element is reappear after regular intervals in some other element. Basing on this, he proposed a law which is widely known as Mendeleev's Periodic Law. According to Mendeleev's Periodic Law, the physical and chemical properties of elements are periodic function of their atomic masses. The physical and chemical properties of elements are periodic function of their atomic masses. What does it mean? It means when atoms are arranged in increasing order of their atomic weights, then a property that was observed in one element will reappear in some other element after a fixed number of elements. By that way, he arranged elements. So far, at the time, he has observed nearly 63 elements, and he studied the properties of those 63 elements. Basing on those properties and considering their atomic weights, he arranged the atoms as a table. In that table, elements are arranged in vertical columns and horizontal rows. That table is said to be Mendeleev's periodic table. This Mendeleev's periodic table, elements are arranged in horizontal rows and in vertical columns. The horizontal rows are called as periods and vertical columns are called as groups. Let us see how he arranged the elements of the periodic table. Mendeleev arranged the elements. So far, he identified and studied the properties of elements, nearly 63 elements properties he studied. And according to the Mendeleev's periodic law, that is, the physical and chemical properties of elements are periodic function of their atomic masses. That means, if we arrange the elements in increasing order of their atomic masses, the regular reappearance of properties will observe. Basing on this, he arranged the atoms in vertical columns and horizontal rows. The vertical columns are called as groups and horizontal rows are called as periods. By that way, he arranged elements in 8 vertical columns and 12 horizontal rows. These 8 vertical columns are called as groups. In all these groups, again he divided each group into 2 subgroups, A and B. This is first group, and the elements present the left hand side are group A and right hand side are group B. Similarly, in each group you have some elements in the right hand side and some elements on the left hand side. So he divided the group, each group into 2 subgroups except for 8th group. In first row, he kept only hydrogen. No other atom is present in the first row. Then he has taken lithium as the first element in the second row. Then beryllium, boron, carbon, nitrogen, oxygen and fluorine, which was kept in 7th group. Then in third row, he has taken sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. That is we can consider it as a third period. Now in fourth row, he has taken potassium, calcium. Here he kept two gaps here to find out the element's later stages. So here, if this titanium should present here, if he has followed only atomic masses as the criteria, he should have kept titanium here or here. But this titanium is not related with the properties of either boron or aluminum. That's why he left one place for element which has to be discovered in future. And he predicted the atomic weight also. Here he predicted that the atomic weight of the element is 44. And he named that element as eka-boron because it is below boron. He called it as eka-boron. But on later stages, scientists had identified an element named scandium. This was the prediction of Mendeleev. Scandium was not discovered when he proposed this periodic table. But he found a large gap between the properties of calcium and titanium. So he kept one place, he reserved one place, and he also predicted its properties, including its molecular weight. That is atomic weight. So his predicted atomic weight is 44. Now it was found that scandium is having atomic weight 44.1. By that way, Mendeleev has made a path for the discovery of so many unidentified elements during that time only. So he named that element as eka-boron. This is named as eka-boron. But later it was identified as scandium, and its atomic weight is 44.1, is very near to his prediction. Then titanium, vanadium, chromium, manganese, ferrous, cobalt and nickel. Now in fifth row, again he arranged copper, zinc. Then he made two places gaps because arsenic is entirely a non-metal, it is a metalloid. So he found so many properties because titanium properties or silicon properties or aluminum properties are not matching with arsenic. That's why he kept arsenic away from this and he kept it below the phosphorus because he was not blindly followed the atomic masses. He has taken atomic mass into consideration, but he has given more important for the properties because the main purpose for the classification is to study the properties of elements. Since they are matching, he kept the gaps like that and he predicted the properties of the elements that has to be discovered later, and it gives a right path for the other scientists to identify such elements. So he named this element as eka-aluminium, then later it was found as gallium. And he named this element as eka-silicon, later it was found as germanium. So this is the great contribution of Mendeleev, because he kept gaps for the elements to be discovered, and he also assumed their characteristic properties. So if they know the characteristic properties and the atomic masses, it makes easy for the other scientists to discover such undiscovered elements. This is the main advantage of Mendeleev's periodic table. The undiscovered elements which were not so far discovered during that time were easily be discovered with the help of these Mendeleev's predictions. This will be the most important contribution of Mendeleev for the discovery of new elements. By that way he arranged elements. He kept so many gaps. Later on, all those elements were discovered and present day, now we are having nearly 119 elements. Of course, only 92 are naturally occurring elements. The rest of the elements are artificial elements. But discovery of all these elements is possible because of this Mendeleev's effort. That's why though nowadays this Mendeleev's periodic table is not suitable for us, but it gives a great privilege for the scientists to discover new elements and arrange them in different patterns. These are the important characteristic properties of Mendeleev's periodic table.